Jai Hind everyone, myself Sandeep Yadav, Assistant Professor, CSC Department. Today I am going to deliver a lecture on Relational Algebra, which is a part of DBMS syllabus being taught in BTech 5th semester in CS and allied branches, as well as it is also taught in MC also. So, the topic of today is Relational Algebra. We will be covering the following topics: selection, projection, Cartesian product, joins, set operators, division, rename, aggregate function and all. Now, first of all, as we are discussing relational algebra, so first of all we should know what is relational algebra. So, relational algebra is a procedural language that is used to manipulate various relations and performs various types of operations on that. Basically, the very purpose of relational algebra is to manipulate relations so as to operate desired results. Procedural language means that here we have to specify. Procedural language means that we need to specify what data is required and how to obtain the data, right? That is the procedural language. And why we are studying relational algebra? The reason is that relational algebra is very important as it lays the foundation of relational database. Secondly, some of the concept of relational algebra are directly incorporated in SQL. Thirdly, it is a basis for optimizing and implementing queries in SQL. So, this relational algebra is of utmost importance to all the series of this lectures. So, first of all, we will be studying the selection operator, which is denoted by the operator sigma, and this is the sigma. Now, this is the notation that this is the condition here followed by the name of relation. Now, this selection operation is actually used to select those tuples from a relation that satisfies a condition. Now, there may be one condition or more than one condition. Now, condition can be both or more than two, up to n conditions are possible. So, using these operations we perform horizontal partitioning. Horizontal partitioning means this operation splits our relation into two parts, one into those which satisfy the conditions and one which do not satisfy the conditions. That is how we obtain the desired result. Now, various operators that are used are equal to, less than, equal to, greater than, less than, equal to, greater than, equal to, and operation, as well as the OR operations. Now, for example, we want to display the details of the student belonging to C branch. So, we want the output of only CE branch student. So, how to obtain that? Means we have to divide our table into two parts. One, the student belonging to C branch, and one who does not belonging to CE branch. That is, the fragmentation is row wise. That is, it is the horizontal fragmentation or partitioning. Thereby, the entire table shall be split, and the desired is the one which are satisfying our conditions. So, we have to now write down the query for that, that is pi, that is sigma. Now, in the sigma, in the subscript we have to specify the condition. Condition is branch equal to C, followed by the name of the relation. Now, what shall be the answer? this is the query in relational algebra. Now the answer shall be this one, that 101 Raju C branch SPI 8, second 104 name is Meet C branch and 9. So we are getting this answer. We are getting certain tuples based on the given conditions. So this entire operation is giving you certain tuples or rows based on the conditions given. Now let us see one more example. Now we are having two conditions. We have to show the detail of the student belonging to C branch and having SPI more than 8. Now we have to satisfy two conditions. First, that branch equal to CE and SPI greater than 8. So there are two conditions that need to be specified in the condition in the below the sigma, that is in the subscript. So how to write it? Like this: sigma branch equal to CE and, this is for AND operation, and SPI greater than 8. Thereafter we shall write the name of the relation. The name of relation is student. So this will fetch us the desired result, and the result will be this one. Since we have to satisfy both conditions, so first row will be eliminated in the result. This row will be eliminated, this will be eliminated, this will be eliminated. This does not belong to C branch, so they are eliminated. This is belonging to CE, and but this does not meet the condition. SPI is 8. So the only answer left is this one. So desired answer will be 104, meet CE, and SPI is 9. This is how we shall obtain the result. Now let us consider one more thing. Now we have to display the detail of the student who belong to CI or ME branch. Now in this example we have to specify both condition, that is the branch equal to CI or the branch equal to ME. So this is OR operation. The condition is either this or this. So the output will be showing the student of CI branches as well as of mechanical branch. So the answer will be like this: branch is ME and branch is CI. We have to watch carefully whether both conditions are required. If both of conditions are required, then we have to use AND operation, and if either one of has to be fulfilled, then we have to use OR. Now let us see one more example to demonstrate it further. Find out the detail of the student where the SPI is between 7 and 9. So SPI has to be greater than 7 and SPI has to be less than 9. So that is, in this example, this is how we shall write it. The SPI less than 9 is 8. So this one will be the answer, rest will not be the answer. Next is project operation. Now suppose we want to find out only the name of the students. We do not require all the details, that is we want to show certain attributes only. We do not want to show all the attributes. If we want to display certain attributes, then select operation is not at all valid at that moment of time. Since now we have to fragment our relation vertically, the fragmentation has to be vertically, that it has to be column wise. For performing the partitioning column wise, we have to make use of projection operator, that is denoted by the symbol pi. This is the notation, it is noted by symbol pi. Thereafter the notation is pi, then we have to write down the attributes. Now the attribute can be n number of attributes, right? There may be n number of attribute, A1, A2 up to AN. How many attributes we want to display? We can write those number of attributes here. That is, this operation works in this manner. It specifies the attributes of the relation, that is the partitioning has to be done vertically only. So the partitioning is done vertically here, whereas in selection the partitioning was done horizontally. That is the fundamental difference between both of them. Now this removes the duplicate tuples from the results. Now we shall see through an example. We want to display the roll number, name and branch of all the students. So these are the attributes that we want in the results. So how will we be proceeding? First we will be using the symbol pi. In the subscript we need to mention the roll number, name and branch followed by the name of the relation student. So this is how we will write the corresponding query: pi, roll number, name, branch followed by the name of the relation student. That will fetch us the desired result. The desired result will be in the following form: first attribute roll number, second one is name, third one is branch. Now here you will get all the three attributes. Now we are missing which one? SPI. Since we don't want that in the desired result, so we will be mentioning like this only. These are the desired attributes which want in our output. Now let us see, but in actual real time our approach is to make use of both selection as well as the projection operations, because we want horizontal partitioning also as well as the vertical partitioning. We want to find out certain attributes based on certain conditions. That is, for example, you want to display the name and branch of mechanical branch student only. We want to show the result and name of mechanical branch only. So condition is there that the student must belong to the mechanical branch. So for mentioning the condition we need to use select operation, and to display this one we have to use project operation. These all the attributes roll number, name and branch shall be displayed with the help of project operation, and the branch shall be mentioned with the help of branch name is a condition which we shall be using selection operation. So this is how we are going to make query. First we will be step 1, we will be mentioning the condition branch equal to mechanical. Thereafter second step, the output will like in this form. Then next step, now we want these particular attributes. So the final query will be like this only. We want roll number, name, branch, and the relation is that branch name equal to ME followed by the name of the student. So this is how we will be writing the query for this particular situation. Now output we are seeing 102 Mitesh and ME. So based on the condition that branch is ME, so it will be displaying us the result of only ME branch. Now this we can also write the corresponding query in SQL. So how to write that? First we have to mention select, what are the attributes required? Roll number, name, branch. Then we need to specify the table from the table student where branch equal to ME. This is how we are going to write the query. Now let us demonstrate further with one more example. We have to display the branch, name and SPI of student where SPI is greater than 8. Now the condition here is SPI has to be greater than 8. So we will be using selection operation to specify the condition that the branch name and SPI can be displayed for only those branch having SPI greater than 8. So, first step is we have to first specify the condition. Now, remember one thing, that if we are using both operations, select operation as well as the project operation, then first we have to write the project operation, thereafter we shall write the select operation. This is how we are going to write. First we will apply the project operation. So, the conditions, so that the attributes names are being specified, name, branch and SPI. The condition is SPI greater than 8 followed by the name of the relation student. So, the order is, first the project operation has to be there, thereafter we will be applying the selection operation. This is how the query will work, and we will get the desired output, name, branch and SPI. The names are Mitesh, ME and 9 SPI, Nilesh, CI and the 9 SPI. Now, here in this particular example, there are two conditions that need to be specified, which we again can easily specify using the select operation, and we can also show these, display these attributes using select operation. We will directly come to the query now. Pi, name, branch and SPI, and condition is branch equal to C, and now we have to see this, we have to use AND here. Because condition include both C branch and SPI greater than 7. So, AND has to be used here, not OR, and we will get the desired outcome as seen in the output, Raju, CE and 8. Now, this one is, we have to display the name of the student along with the branch who belong to either ME or CI. Now, here the operation that has to be used is OR operation in the condition. But one thing we must clearly know is that we have to write branch equal to ME or branch equal to CI. We cannot write branch equal to ME or CI. We have to mention branch equal to ME or branch equal to CI, and here we represent the various attribute, that is name and the branch, and this is the name of the relation student. Now, next operation is Cartesian product, that we know very well, that is represented by the symbol cross. Suppose there are two relation R and R2 and we want Cartesian product, then this is denoted by R1 Cartesian product R2, or in algebra algebra 1 into algebra 2. It will multiply each tuple of relation 1 to each tuple of relation 2. So, attribute, how many attributes shall be of the resultant expression? The attribute of relation 1 plus attribute of relation 2, and tuples, how many tuples will be there? Tuples will be of result tuples of relation 1 and multiplied by tuple of relation 2, that is 2 into 2 is 4. That is, if there are m tuple in relation R1 and n tuple in relation R2, then the total number of tuples will be m cross n. Let us see this example. Now, see step by step. Now, first this will cross product with this, thereafter this one, first row of this with first row of this, thereafter first row of this with second row of this, thereafter second row of first is with first row of this, and now second row of this with second row of this. This is how the cross product will work, and this will the final output, student dot roll number, name, branch, result dot roll number and SPI. So, in total we are getting all the possible number of combination, and total output will be 2 into 2, that is 4 tuples will be in the output. This is how the cross product works. As such, cross product is useless unless we have certain more conditions, but it is fetching data from more than two relations, so it can also be known as Cartesian join. One thing to note is, if both relation have some attribute with same name, then we need to specify them by relation name dot attribute name. That is, here this roll number is coming from student table, so we have to specify student dot roll number, and this roll number is coming from result, so we have to append the name of relation before the name of attribute if both of them are shown in the result. Now this is again we are performing the cross product between the student and the relation, so we will be getting the answer in this form only. Now next is natural join or inner join, which is denoted by this symbol, and this is demonstrated in this way: relation R1 cross join join relation R2. Now this operation will retrieve data from multiple relation based on certain condition. Now the various steps are: it will perform the Cartesian product, thereafter it will delete the inconsistent tuple, then it removes an attribute from the duplicate attributes. Now let us see the example of natural join. So whenever we have to fetch data from more than one table, then we have to make use of join. So join operation is basically used in DBMS when we want to fetch data from more than one table. If we have to fetch data from more than one table, then we have to make use of join operation. Now how to write the query for that is student natural join result. So the output will be in the following form. Now one thing very important is that one attribute must be common in both the relations, that is roll number. Now the output will be roll number, name, branch and SPI. First, how it happens, how we are getting this output is, first the cross product is there, then we have to remove inconsistent tuples which are no longer desired. That is 103 is here but not here, 120 is here but not here. So they will be eliminated and you will get the final answer is. Now we are removing all the inconsistent tuples. Now remove an duplicate attribute. Which one is duplicate? Roll number. It is repeated twice, so you need to remove this one from here. So the final answer will be roll number, name, branch and SPI. This is how the cross join, this natural join will be there, but it has to be used only when the data is to be fetched from more than one relation. Now we have to perform one more example can be demonstrated. We have to perform natural join between branch and the faculty. So we can easily do that. Branch natural join faculty. So output will be this one: BID, B name, HOD, FID and F name. Now one thing more, which one attribute is common? This attribute is common in both of these relations, this one and this one. So one attribute has to be common, one attribute has to be common. Outer join. Now in natural join some record are missing, that is some are present in one table but not present in other table. So if we want to show this missing attribute also, we have to use the outer join. Outer join is of three types. First is left outer join, specified like this, right outer join specified like this, and full outer join like this. To perform an outer join, there must be one common attribute between the relations. Let us see left outer join. it will display all the tuples of left relation even though there is no matching tuple in the right relation. So this is used to display all the rows of left relation even though there is no match in the right relation. So for this, let us see it with the help of example. If we use natural join, the answer will be only this one, 101 Raj and C. But since we want to show 102 also, we will be using left outer join. This is how it works. Student left outer join result. So this value 102 which is not present in right will also be shown in this way. Now the right outer join. Now we want to show 103 though it is not present here, so that we can be using left outer join, right outer join. 103 branch is not there. There is no entry for 103 here, so branch will be null and name will be null here. Both of them are null because their corresponding value is not present in left table and SPI is 9. So this we can show with the help of right outer join. Now full outer join. This is the notation of full outer join. Now we want to display all the mismatched tuples of both relations. Then we can use left outer join. It pads null value wherever it is required. Let us show with the help of an example. Now we have to perform. We want to show 102 as well as 103 in relation. 102 is not present in result and 103 is not present in student, and we want to show them in the result. So in these situations we have to make use of full outer join. Let us see how it works. Now student full outer join result, roll number, name, branch and SPI. 102 meet ME. Now this is not present in right relation, so 102 is not here, so this value is null here. Now 103 is present in this one, so this value is 103. Now this corresponding value of name and branch is not present here, so these will be written null null and SPI is 9. This is how this query will work out. I hope every one of you is clear with this, and with this we come to the end of this lecture. Thank you.